Okay, we are waiting to see whether or not this is working. I want to know if we've got audio, and we've got a yellow bar on YouTube. That's good. Is this going to work? It worked last time. Let's see. Do we have audio? We have audio. I want to know. Good. Right, so let's hope this stays together even though we've got the yellow bar on YouTube. We're hoping for that anyway. So this is a BenQ GL2450 LCD monitor out of the trash as always, and I turned it on. At first I thought it was just fine, but then I noticed it's very dark. So you can see these monitors are of a pretty similar vintage. This one's cranked to 100% brightness, that one isn't. So this is a very dark monitor. It's really... there's no real reason for it to be this dark, because I've been in the service menu for it, and we can just enter there right away and have a quick dig around to see how much this has actually been running. People are showing up in the chat, that's good. Hello everyone. So to get into the service menu on this, you hold menu, press power, and you wait a while and hope that you don't lose input signal. And then you should just menu again and you get the service menu. So if we have a look at this, this thing's got only 6,000 backlight hours. Is that entirely out of focus? That looks entirely out of focus. I'm going to manual focus on this thing. We are manual focus, give me a sec. We're being professional. Focus. Auto. That should be better. Yeah, it's 6,000 backlight hours, so there's no reason for this to be as dark as it is, because the LEDs really should have a longer life than that, even at maximum brightness. So I'm thinking probably LED driver issue or power supply for the LED driver issue. I have seen a couple of roughly this vintage BenQ monitors explode their LED drivers. So I'm thinking we're going to start just tearing it utterly apart and having a visual. I've seen some very hot running LED drivers in these similar vintage BenQ monitors. So there's a decent chance it's basically just tried to go on fire, and it's just kind of half died in the process, just like my camera mount. That's the best you're gonna get. So let's just tear into this thing and see what the process will look. We're not hoping to make quick work out of this. I've been inside so many of these. Well, similar BenQs anyway. That shouldn't be much of a challenge. Just going to rush through it basically. I'm not going to have a time to look at the chat too much, I don't think. Where is my small screwdriver? I need a small screwdriver to get this horrible foot off. These are a pain because they tend to just stick horribly. There you go. Get rid of that. Screws underneath there. That's the entirely wrong screwdriver. Need a Phillips 2 for that. Phillips 2, couple screws, and you just pry them apart like all the others. Nothing special. So, for reference, this is a GL2450B. Type GL2450, manufactured July 2012. A bunch of serial numbers and stuff on there, which we don't care about. So let's just rip this thing apart, see how quickly we can do that. That's this particular. Oh, that's an annoyingly stiff frame of that. But look on top. There we go. There we go. Bunch of finger marks there. It's either been carried or someone else has been trying to get inside this thing. Or someone else has been inside. I don't know. It's out of the trash. Rip, tear, crack, pop. You really don't need to be too careful about these. There we go. Do I have a connector? We do have a connector on that. Snip. Yuck. All dirty and disgusting, this thing. Oh. a god, I'm colliding with all my other stands. Let's just see what we've got. Flip it, drop it, and screws for light. As the box LED plug comes out, we need to up our exposure because that is way too dark. That ought to be better. There we go. That's the front panel plug coming out of a scaler, and that should be all we... Oh yeah, well, of course we've got the LVDS going there. Can't just tear that out. There we go. That ought to be our modules. Rip the power supply out because that's most likely where the issue is. Because the scalers, well, they do fail sometimes. They're just failing brain deaf. Usually they don't tend to go cause dark picture, especially not on the drive LEDs. I think these are advertised as flicker free, so yeah, could be some linear rubbish going on. Probably not. I can see we have some discoloration in this part of the board, so I guarantee this is the LED driver and it's going to be completely dark and horrible on the top, because they tend to do that because they are undersized. And yeah, there we go. Ugh, how disgusting. How utterly disgusting. Oh, we could have a charged mains cap actually, since this thing was on a moment ago. Let's just a quick work of that. Yeah, that's fine. Rightio. This could be an annoying repair. Let's hope that we'll get away with replacing the caps right here and adding some cooling, because it hasn't... Oh wow, that's really warm actually. Oh, have we fried the choke? Have we actually fried the choke in this? It almost looks as if that choke has run so hot that it's melted, because it feels really, really crusty. No obviously broken solder joints, which is a miracle. So I want to rip out the capacitor tester and see what these caps look like. Could just swap them and try, but I prefer to be somewhat scientific, so I'm going to rip out the horrible proprietary capacitor tester, which you guys never get to see, and also not drop my pants. And it's somewhere in all this clutter. This workshop is an absolutely horrendous mess, because it looks as if we're actually going to be moving shops quite soon, next couple of months, so I'm just letting everything deteriorate because I really can't be bothered cleaning this horrible space up since we're letting it go. Where the hell's my cap tester? How can I possibly lose something which is permanently attached to a USB cord and always somewhere around here? And it's got a couple of really sharp probes attached to it. Oh, there we go. There it is. Stuck in a million random things. And a USB cord. Oh, my all-out frame. There we go. Proprietary cap tester. Click. And where's my USB? There's my USB. And click. Detected. I'm not sure where my software is, but this thing has an internal 4 MB flash, so I can just grab it straight off the meter. There we go. Perhaps you can even see that. Hi, you should be able to. DC resistance, 0 over leads, because this thing is a robot prototype and has no memory. 0. And you absolutely cannot read that text now, can you? Let's fix that with some manual zooming. I would use a remote, but this lovely Panasonic camcorder can either do remote control or it can do HDMI out. It can't do both remote control and HDMI out, so it's we're pretty screwed. Get some light in there. Both my IKEA lights. So let's just put this in ESR and see. So these caps are supposed to be 330 microfarad, 35 volts. These guys here, and these brown Chemicon clones, there are 22 microfarads, 100 volts. So these guys are the output caps for the inverter. Most probably these are the input caps. So there's a boost converter, boost choke there, switching transistor there, and probably a rectifier diode there. So most likely just bad caps, perhaps bad choke in this particular unit, and we could also have like a horrible leaky FET which has just been running too hot. So caps are those pads there. Let's just see what we measure. 70 milliohms, 600 microfarads across there. That's better than I expected actually. And that one's 70 milliohms, 680. So these are obviously in parallel, so they are going to measure a bit higher capacitance than they would alone, but I really want to desolder those and see. And while the desoldering pump is heating up, which I of course forgot to turn on, we'll just test the 22 microfarad 100 volt ones. I'm not sure if I have any good replacement for those. I'll have to see. Hopefully they're not bad. If they're not bad, I'll just ignore the fact they've been running incredibly hot. 44 microfarads for both of them, 270 milliamps. So that's fine, really. That's absolutely perfect. Nothing wrong with those. So we can just let those be, even though we've got a giant brown discoloration of a board right there, right next to the caps. You know, that's great. But, oh, geez, this choke is so fried. I almost want to take the shrink wrap up just to see how bad that is, because that really is horrible. Absolutely horrendous. Oh, and we just fix our exposure. Zoom in a bit more. And can you focus on that? You can't focus on that. Come on. That is so blackened and horrible, that choke. That guy is not happy at all. And what's something over there? What's been running hot? Yeah, that's the switching transistor made a hot spot. And we've got one dark spot for the switching transistor, one dark spot for the choke. So we're starting to get these desoldering pump heated. It says 420. So we will let it smoke weed every day, and geez, I'm going to zoom out back out of the cap tester because else you can't see anything of what I'm doing, really. Zoom. Because screen captures for pussies. Rightio. Some water there. Fill the sponge. Probably zoom that back out there as well. There we go. Oh, it's not clogged. thing about these desoldering pumps is they basically always clog. If you're using them, you are unclogging them all the time. So the negative markings on these caps are fine. I can just undo them without memorizing which way they go in. That's one out. And there's the other one. I'm so hoping these are the issue, because if these guys are not the issue, then we'll probably have a bad choke, most likely. I could have issues with the main rectifier caps there as well. Perhaps I need to check those, but I'm more curious about these guys for the LED driver. That's measuring 100 milliohms, 340 microfarads. That's a bit on the high side of impedance wise. Other one's 100 milliohms as well. Perhaps a bit on the high side, not really terrible. Let's see if I have something kind of comparable. I should have a bunch of 470 35s of some description. No, I don't. I don't think I have 330s. I do not think I have 330s. I do not have 330s. But I should have about 1 million used 470 35s out of some old modem kind of dealy. Well, I have one used for 470 35, so we can just compare. If this is a pretty crappy cap, not a very low ESR Rubicon YXF series. Oh, come on, get measured. So if we have a considerable lower impedance than this than 100 milliohms, then these caps are potentially bad. And we are seeing horrible connection because these legs are all corroded, rather oxidized. I'm seeing about 100 milliohms, but I'm not making a good connection. I really am not managing good connections. I will have to just tin those. This cap has been lying around forever. Tinned. $85 milliohms, so yeah, I don't think those caps are actually our problem. I'm going to replace them anyway, since I just desoldered them, and I should have some kind of replacement somewhere, like more of these recycled caps somewhere. Was this 1525? That's not going to do. How can I not have? I have 680 microfarad. I have 680 35, but they're giant. Do I have 1035? I could just put one cap instead of two. I know I can't because they're on two sides of a choke, so I really need two caps. Well, that's annoying. I'm going to have a dig in my extra components. Drawer, hoping I'll get some kind of cap which can go in there. And I can't imagine that I wouldn't, because 470 35 is a very, very common value. So if I don't have them, I really should be getting them. Well, I have 1035. That's not much good. 470 25 and 470 16. Oh, come on. What are these? 1025. This has not gone well. This has not gone well. I can't believe I would be out of my my second-hand recycled 470 35, because I had like 50 off of them, which I desoldered off of old boards. Oh jeez. There. So then what? We're gonna have to put 680/35 is the closest we have, I guess. But they are ridiculously giant. Are they going to fit height-wise? Yeah, they're going to clear the case, so we're in for an upgrade. Perhaps I have something like 220/35 I can put. Like 1680, 220, that would do. I don't know. 220, oh no, 220/35. Good. So, instead of a 330/35, we're going to put 1680 and 220. So, the one which goes, I'll zoom in a bit. The one which goes here is going to be closer to the power supply because it's closer to a diode physically. So, I don't know, hang on. Are these not even separated by a choke? No, these guys are straight in parallel. Wow. You can see the caps go there and there. Usually when you have two caps you have a choke in series here, but they've just omitted that. They don't even have a place for one, so they're just literally in parallel. The one going here is, I don't even know what they're supposed to be doing. There's actually really poor decoupling of the LED driver, because they're going to the choke, which is over here, all the way over there. Huh, that's not very good. So we probably want the bigger cap actually here, closer to the LED driver. Or we could put the smaller one there. Yeah, let's put the smaller one there, potentially giving it a bit more resistance to the choke, just to perhaps cause a bit less energy to be dissipated in it. I don't think this is going to make much of a difference. Oh no, hang on, I did have one second-hand recycled 470/35, so we'll just put that there. When I say second-hand recycled, I got these caps out of a whole bunch of cable modems which were being thrown out because they were outdated. They were never sold, never used. They'd just been bought by some telecom and got to sit on the shelf for a few years, and when they threw them out, when they just retired the entire service. I was just, hang on, I can use these AC adapters, I can use these parts. I'm going to spend an afternoon desoldering things, and I have like 100 10 volts DC 1.2 amp transformer based power supplies from the Stone Age, which are used for everything. They're great. There we go, there's new caps installed. But I also want to check these guys. These are 680/16. They shouldn't have much to do with the LED driver, because they're for the 12 volt rail, probably feeding the logic, but let's just measure them. In a way, in case they are going bad. What are you? We're looking at like 2000 microfarads, under 100 milliohms for these. Oh no, not 2000, they're 680, so like 1400 and above basically, and we're seeing 75 milliohms, so yeah, 1600 mics. So these guys are good enough. We've got have a 2225 over here, which we want to check out as well. Seems to be some kind of step down converter there. Alright. And that one measures 128 milliohms. It seems to be in parallel with the two 16 volt guys over there, so I think that's good enough really. I'll have a tiny 50 volt 22 on the primary side. That one's going to be good, else the power supply probably wouldn't start. 2 ohms, 19 mics, that's fine. So I don't think we have any further capacitor issues. On on this board. So what I'm going to do now is redo a few solder joints by the LED driver, and for that I'm going to give you guys, let's see, zoom and tele macro enable, and now you guys are going to have a very good view of my soldering. So let's move to the LED driver. Where's that? These are the solder joints for the choke, so they look pretty good, but I want to redo them anyway, just for the sake of it, because thermal cycling and thermal stress will destroy solder joints in time. There we go. And do I have anything more around here which needs redoing? So there's our tiny rectifier diode for the LED driver. There's our switching transistor. Looking fine. And we really should add some heat sinking here, because this is not enough by any stretch of the imagination. We have a little bit of space above the board, like above here, so I could just add, I'm not sure if I have any copper fins from the laptop heat sinks lying around. Let's just have a quick dig in the box. No fins from laptop heat sinks. Oh yeah, we do have one fin, one very worn and tattered fin, but it's going to be good enough, I think. So we'll just best solder that on there, and it'll help slightly alleviate the thermal issue. So I'll just flow a shit ton of solder on there, heat it up nice and hot. There we go. And we'll flow some. I need to cut this piece slightly. Where are my pliers? Just to cut this thing off like so. Snip. That gives us some fresh copper, which we can tin. Let's see if we can even get the tinning process on camera. Okay, that's just going to be probably impossible. Maybe, maybe not. Oh, there we go. Kind of out of focus, but it'll do. And we're going for that corner. Big soldering on. Solder. That's good. And now we remember that that's very hot, so we don't grab it with bare fingers. Just use tweezers, always use protection, put it somewhere right there. And we'll just goop that on there. We're not shorting anything out, no. Good. There we go. Now we can even solder that to the diode, since it's stretching it all the way over there. That'll give it a bit more mechanical stability as well. No fresh copper to work with, maybe we can... Oh yeah, we've achieved tinning anyway. There we go. Lower impedance track, a bit of extra cooling. I can trim this down slightly so there's no risk it'll short out across the choke and destroy things. Snip. Where's the camera? There's the camera. Snip. 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 That's a cute little heatsink. That's going to improve our thermals. Just a tad. It's going slightly above the board, so it should be alright. It should be alright. We should have enough space in the case to accommodate that as well. No. Yeah, that's as much time as I think we're gonna put on this LED driver, because I still fear the choke might be absolutely destroyed. So let's just put this back together and see if it's going to work now. I think it's still going to be very dark because the choke's a dick, basically. So that goes in there. That goes in there. We'll have a bunch of screws somewhere. Like, if this doesn't work, then this thing is basically just garbage. Until, like, I'm probably going to get my hands on a fitting power supply at some point, so I'm just going to throw this in a corner and forget about it. Oh, that's excellent thread. Excellent threading. I like how they've actually done away with the plastic they used to have on the backside of a power supply. They've just gone with slightly more spacing against the panel instead, because the board used to be mounted further up closer to the display panel, and there was a risk of arcing if they didn't install a plastic plate between them. But they've done away with a plastic plate and made a thicker monitor instead. I do like that. That's a good initiative. Makes them more serviceable, makes them bigger, makes them sturdier. Probably makes them cheaper since they chose to do it. On you go. On you go. You go there. You go there. You go there. Click ziff. Ziff has to be in straight. Ziff. And LEDs. And we'll flip this over, give it front panel, flip. Ugh. Oh no, don't destroy yourself. Did we just destroy a flat flex fan now? Oh, we did. And bezel with front panel comes here. Oh, there's an annoying flat flex. This is a really annoying flat flex. And now I'm just planting the display parts all over my soldering iron, so we're about to go on fire, but that's okay. I'm assuming you just see my haircut right now. It's wonderful. I wish I had someone to be my free labour cameraman. That would make life so much easier. It's easier if you lose Rossman, then you just have your microscope camera and your background camera and you're set. Not as easy when you're doing work on random big things. How the hell does this ZIF socket work on this? This has some weird ZIF connector I've never seen before. All the plastic cases just in the way so that we can't actually get... Oh yeah, it's one of those normal ones that flip up. It's just the case was in the way, so in you go. Oh, this is annoying. In you go. Come on. Zip, click. Good. Okay. So let's see if this thing is alive, if the issue has been resolved. Again, I think it's probably done for, and it's going to need a new choke, and I don't have that, so it's going to get basically scrapped. Ugh, power. And, oh yeah, I forgot the LVDS. Oh, that looked very dim and horrible. Let's just give it some signal and see, like, yeah, it's washing out white, like that's full white. It's turned on saying no signal. Not good. Like, it should be brighter than that, but let's turn it off, connect the LVDS, and see. Yeah, we can adjust for brightness, see what happens. I am not going to manually wind a new choke for this, that's for sure. Ah, come on. Click. LVDS, and we've got VGA. VGA goes in blue hole. There we go. Power on. Lights out. This is incredibly dark still. We should have signal very dark. Menu. These are impossible to use. Brightness 100. How do you, I think, advance the button, enter, enter. What happens if we're trying to adjust for brightness? Here, going down. It does actually manage to get darker still. Wow. This is a very, very dark monitor. An incredibly dark monitor, actually. That could have its applications. Like, in a way, I don't mind that. But yeah. It's not going to be serviceable for any kind of normal application at all. And the LED driver is probably going to basically go on fire if it keeps running. So this thing is toast. What a shame. What a shame. I do have a bunch of random chokes lying around, but I don't think anything would really work very well in there. I don't have a donor board. What a shame. How much power does this thing draw at 100% brightness? It's drawing 7 watts at 0% brightness, which seems too much given the amount of light it's putting out. I think it's rated for like 34 watts under normal operating maximum. Oh, come on. So if it draws anywhere near 34 watts at full brightness, then we have a lot of power getting wasted somewhere. But now it's drawing 10 watts. So perhaps the LED driver actually isn't running all that hot. It could just be running inefficiently, like not passing enough current through the choke because there's not enough inductance left in the choke for it to work properly. No markings on the choke either. Like, I do have these random chokes I got for a project a long time ago, which I never got around to actually using. But most of them are kind of high current. These are 22 microhenries, like they're probably way too small. Maybe something like this. What's this? This is LHL 13TB101K. Here. That tells me nothing. Pretty thick leads, so they're probably high current. Most of these are very high current. I should have a bunch of like 100-ish microhenry, but I think that's too little. And these are like, these giant guys are 100 microhenries, giant current rated. We could just try and swap one of these in for fun, not for fuck, and just to see what happens, because this thing's basically trash anyway. Let's just do that. It takes but a minute. I'm curious. I am curious. So this thing comes apart again. We don't need to undo the front panel, just the LEDs there. I shouldn't have gotten cocky and put all the screws in, but that's one of those things you never learn. So apart it comes again. Oh wow, this thing runs incredibly hot. Like that was almost too hot to touch, even though it's been turned off for a little while and it was sitting at rather low brightness, so it's certainly not running optimally right now. There's definitely more heat being generated in that transistor than it should. Could be the transistor is balked as well, I mean we don't know that for sure. I haven't tested and I don't have like one of those China component testers, but I suspect the choke. Let's just desolder that. Off you come. Let's just undo this shrink wrap and have a look at what's actually in this choke, because like it looks horribly burnt. On the outside. Where are we? There we are. So give me cutters and let's dig in. Alright, it's making crackling noises at me. That's not a happy choke. That's not a happy choke at all. Exposure, please. Exposure. More exposure. That is not a happy choke. Over. Yeah. The lacquer has definitely been coming off. This thing has run a tad too hot, so we could quite possibly have a few shorted windings around the middle. Just because the lacquer started melting and the coppers moved slightly closer and shorted out. So the question is, how good of a match is this? That's just a random choke out of a box, the biggest one I have. I'm thinking this is a relatively high inductance, since it's a toroidal with quite a few turns. This is not a toroidal with maybe a few more turns, I don't know. Let's just put it in there and see what happens. I mean, I don't really care if this thing goes on fire. It was trash already. This thing might not fit inside the case. Oh, maybe it will. Oh yeah, it will. It's no taller than the cap. So, solder that in place. This is going to be ridiculous. It could just go on fire, destroy itself completely. But at least then we know that that's the incorrect choke. Maybe someone in the chat right now is screaming at me, "I can get those chokes on eBay for 59p. Well, I don't care. eBay's not going to get them here tonight. I'll just mount this in here loosely and plant the panel on top. See if it'll light up. Or we'll just completely destroy the LEDs in the panel as well. And this thing should basically just operate on feedback anyway. So as long as it's not too far off spec, it could work relatively well. LEDs there. Like if we just put power in this thing, it should light up to show the BenQ logo. Brace yourselves. Power off. plug it in. This will be interesting. Well, that's looking better actually. It was drawing 21 watts and it was significantly brighter. I mean, that's not as bright as it's probably supposed to be, but it's a lot better. So I do think we have found the issue. It is the choke. And it's just drawing 20 watts. That's not bad. Maybe this thing is fixed now. Like, if we didn't need absolutely maximum brightness, is this thing going on fire? Oh no, not quite. Like, these things do run ridiculously hot. But this doesn't seem to be fire hazard hot. Okay, let's plug in the LVDS and feed this thing some signal, see what it does. What a ridiculous repair. Here, VGA. In you go. In you go. Power on. BenQ LED. I mean, that is so much better. This is actually serviceable. So, what's our power range for this thing now? Menu. Oh, I didn't plug the OSD in. Annoying. In you go. Stupid keypad. Ziff. I will yiff your ziff. Rightio. Menu. And enter and enter. So our maximum power is 24 watts, which is quite close to spec. Oh god. It does not like being dimmed. It's screaming. Minimum power is 10 watts. Oh, listen to that. It's fine, it's 100, but anything less. And it's incredibly flickery. So I think this choke does not have enough oomph to actually do its job properly. But it does work, and it does make it better, so we have found the issue. No prob. But yeah, not dimmable. Unless you're in an industry. Right, yeah, I'm going to call that a day because I want to do something else. I've been at work all day, so let's have this thing run for a little bit just to see if there's smokes. If smoke's going to come out, you get to enjoy the progress of deban. There you go. Deban for you. And I'm going to check out the chat. 61 people watching. So I'm just going to read the chat from beginning to end since I haven't done that already. Sounds like a backlight inverter. Thank you for the tip. Menu plus power work with my HP. That's not going to work with your HP because that's specific for BenQ. Will that work on my Acer? No, of course it won't. That's manufacturer specific. Check the big Zener diode next to the caps. I don't think there's a Zener diode next to the caps here. I think there's a big rectifier diode next to the caps. How many butt tons are a shit ton? Huh. Won't that copper short that board out? Obviously not. Someone asks, how do you endure 26 degrees in a black long-sleeved hoodie? It's 27 here in Denmark and it's too warm for me even though I'm naked. It's not 26 degrees in this horrible workshop. It is closer to 12. At least down by the floor, which is the only part I care about. Consider that I'm stuck in this horrible basement bunker which has no heating and is underground and is moist and horrible and cold. How many millihenry choke is that? Nobody knows. If you could count the turns on the choke, it could help. Definitely. Greetings from Estonia. We like big booms. I'm sorry to disappoint. This thing doesn't seem to be going boom actually. It's sitting steady at 24 watts. Not bad. Someone likes the monitor at 100% brightness. Are you insane, man? Since it's a simple choke, you could rewind it with old switch mode transformer wire. Very simple, yes, but very tedious. Like, where did that choke even go? Like, this is enough turns for me to consider it annoying to wind. Maybe I will if I feel really, really bored someday, but there's going to be like 50 turns or something like that. And I don't feel like doing that at all. But yeah, this monitor has been troubleshot. We know what's wrong with it, we know how to fix it, and we have made it less horrible. So I'm going to have to thank you for watching, and I hope you enjoy yourselves. Goodbye. In a few seconds when I find my stop button.